Morning, all of you. So, as we know that till last class we have studied what is the physical properties of metals. Now, in our today's class, we'll discuss what is the physical properties of non-metals. So, let us come to here. We have totally 10 physical properties of non-metals. In that, one by one, we will study fastly. Nothing will be there. Very easy. Only it is, except some exceptional cases. So now let us see this physical properties of non-metals is exactly opposite to physical properties of something. What is that, guys? Sumaira? Physical properties
of metals.
physical properties of metals. So now let us see here. The physical properties of non-metals are, as we know that they are opposite to the physical properties of metals. Then the first physical property of non-metals is they are neither malleable nor ductile. What is that, guys? Non-metals are neither malleable not ductile. So means the sense of what, guys? There. So this is the property of metals, main property. The first property of metals is malleability and ductility. But non-metals are not like that. So there are some other thing. What is that, guys? They are what? Non-metals are? You should tell me, non-metals are what? They are neither malleable nor ductile. But what, guys? Non-metals are? Anybody? Another word. What they are?
Sir, they are brittle, sir.
That is what I am asking. But nobody is responding. They are neither malleable nor ductile. But they are what? They are brittle in nature. Understand?
They are brittle in nature.
What do you mean by brittle, Arya? What do you mean by brittle? They
Sir, breaking down of several pieces.
Breaking down of substance.
That is what. So if you take the metals, we can hammer it into thin sheets and we can stretch or drawn into thin wires. But non-metals, it is not possible. So neither be hammered into thin sheets, understand, nor drawn into thin wires. That is why non-metals are brittle. Understand? They will break easily. Understand, guys? So we cannot stretch them or we cannot hammer them. We cannot stretch or hammered. Understand? Hammered, hammered, because they are brittle in nature. So if we take, for example, sulfur and phosphorus. Example, if we take sulfur and phosphorus, metals or non-metals? They are sulfur and phosphorus. Tell me, sulfur and phosphorus, metals or non-metals?
Non-metals.
Brittle in nature, or they are malleable or ductile in nature? They are
Brittle in nature.
why I am taking only sulfur and phosphorus? Anybody can say? Because non-metals, most of the non-metals are, what is that? Liquids and gaseous state. Is it yes or guys? Please respond me. Nobody is answering.
Yes, sir.
If you'll observe here, the non-metals are present in 3 states. Non-metals are present in 3 states. As I said, we have totally how many non-metals? 22 non-metals. Is it yes or no? Do you remember it, guys? Please respond me.
Solid gases and
22
liquids.
non-metals we have totally. In that, how many metal solids are there?
10 solids. 10 solids and 1 liquid and
liquid we have and 11 gases we have.
11 gases, sir. 11 gases.
To show the property of brittleness, which one we can take? Only we will consider the 10 solid non-metals.
Solids and
Liquids and gases we cannot break it. Is it yes or no, guys? Is it possible to
Yes,
break
sir.
the liquids and
no,
gases?
sir.
No, that
No,
is
sir.
why I am taking only when I am taking non-metals are brittle in nature. Which non-metals are? Solid non-metals. What is
Solids.
solid non-metals?
Solid non-metal.
I am taking here 2 non-metals called as, what is that, guys? Please respond me there.
Sulfur and phosphorus.
Understand? So they are called as non-metals, which are non-malleable and non-ductile. So they are brittle in nature. They are brittle in nature, means in the sense of they are non-malleable, and non-ductile. Do you understand, guys? That is what you have to understand. So if you take here, suppose for example, sulfur only, I have a sulfur. Suppose I have a stone of sulfur, and if I'll hit with a hammer, then what will happen, guys? It will be turned into powder. Understand, Ra? It will never be stretched into, understand, any kind of a sheet or wire. It will become powder. The same thing will happen to the carbon. Same thing will happen to the sulfur, etc., etc. So they will be become into pieces. That is why they do not form thin sheets or thin wires. So if you take here, carbon is also, but don't ask, sir, then diamond is also a form of carbon, very strong in nature. It will never become pieces. That is exceptional case. That is well studied. So if you take carbon is also, suppose normally coal. Coal is also what, guys? Coal is a form of what? Coal is a form of what? Carbon. Is respond me. So if you hit with a hammer, what will happen? If it will hit with a hammer, what will happen? It will turn into pieces or not? It will turn into pieces or not? Nobody is answering. Yes. Suppose your pencil lead. Pencil lead is made up of what, Dina? Pencil lead is made up of what? Graphite. Correct or not?
Graphite, sir. Graphite.
Contains what? Graphite contains what? Graphite contains carbon.
Carbon.
With a sharpen, just you are sharpening the pencil. That the graphite is breaking or not? It is breaking into pieces. Is it yes or no?
Yes, sir.
So this property, understanding, which can break easily into pieces, is only we should call as brittleness. What we should call, guys? Brittleness. Understand? Remember this. So breaking easily, anything, any substance breaking easily, we used to call it as brittleness. So all the non-metals, we have how many non-metals? Totally 22 non-metals we have. In that solid non-metals are how many, Akhil Arfan? Only 10.
Yes, sir.
Brittleness property is applicable only for solid non-metals. They are breaking very easily, and that property of breakingness is called as what? Brittleness. Understand, Ram?
Brittleness.
Brittleness is the characteristics property of metals or non-metals? Non-metals. Understand, Ram?
Non-metal.
Non-metals.
If you consider the main thing, this brittleness is only considered for solid non-metals. This is the most important thing. What is that? Solid non-metals. And it is not applicable to what? It is not applicable to liquid and
gas.
Gaseous non-metals. NM means non-metals. Remember that. That is. So this is the first property. Any doubt, Ram? So examples were
No, sir.
sulfur
No,
and
sir.
phosphorus. That is next. Second property, just opposite. You see now, first two properties of metals we combined and we made one single property. That is brittleness in nature. Understand, Ram? For example, see, also we can call it as embrittlement. What we should call it, guys? Embrittlement. That is also you can say brittle, BRITTLE, brittlement. So embrittlement means, for example, do you have a chalk piece? Calcium carbonate, yes or no? Chalk piece, you know, if you will correct. So chalk piece, just in our school you can see while I am writing, just if I will keep it on a board, it will break it into pieces. Is it yes or no?
Yes, sir.
Very less.
Yes, sir.
Chalk, if you take chalk with less force, even while I'm writing itself, it will become into 5-6 pieces. Most of the 80 students they observe. Is it yes, guys? So many chalk pieces I used to use.
Sir.
That is. So this property only easily can break, we can call it as embrittlement. Remember, brittlement or embrittlement also we can.
Embrittlement.
Is easily can break. Easily can break is called as embrittlement or brittlement. That is what shown by a solid non-metals. That is you should remember. Next, second one, non-metals combine now heat and electricity. Non-metals are good conductors or bad conductors? Tarani, Arvind?
Bad conductor.
They do not conduct heat and electricity.
Bad conductors of.
Yes. Non-metals, understand?
Bad conductor of heat.
Do not conduct do not conduct heat and electricity. So, they are what we can say, they are the bad conductors of heat, and as well as they are the bad conductors of electricity. Understand, guys? So, every this is also regarding what, guys? This will be regarding all the non-metals. So if you take non-metals do not conduct heat and electricity because like metals they do not have free electrons. What is that, guys? Do not have what? Free electrons. So if there is no free electrons, it is not possible to gain electrons, or sorry, it is not possible to transfer heat, understand, and electricity also. For example, if you take again two non-metals, what is that names? Just now I said, what is that? Sulfur and
Phosphorus.
Phosphorus.
Understand? So phosphorus. Exceptional cases will be there. That you no need to worry.
Graphite, sir.
Yeah. So phosphorus, if you will take. So they are the non-metals which do not conduct what? Do not conduct heat as well as electricity. So now, if you will take one and only exemption is there. That is what I should say. So if you will take here, that is graphite. Graphite is also not for heat. Anybody can say not for heat. It is only for what?
Sir, only for electricity.
Only for
Electricity.
So only one exemption we have. Understand, right? So only one exemption. That is also, you can observe very carefully, carbon. So this carbon is also, if you'll observe three things I will say, be very careful. So carbon in the form of what, guys? In the form of graphite.
Graphite.
In the form of graphite, it is the good conductor of electricity. What is that? Good conductor.
Good conductor of electricity.
Conductor of electricity. Next, in the form of diamond. Carbon in the form of diamond. In the form of diamond, it is the good conductor of heat. Good conductor of heat. Remember, guys, diamond is having one of the best conductor of heat, and graphite is good conductor of electricity. Understand, Ra? But diamond cannot conduct electricity, and same way graphite cannot conduct heat. That is, you should remember. Now, one more thing. We have another form of carbon. That is what I said. Fullerenes. What is that called as? Fullerenes. Understanding, Ra? Best example, C60. Buckminster Fuller. What we should call? Buck. B-U-C-K. Buckminster Fullerenes. Understanding? Fullerenes. Example, that name is called as C60. So this is also third allotropy of carbon. What is that? Allotropy of carbon only. So it is present where? I said already. Yalni, can you able to say where it is present? Anybody, Harini? Where it is present? I already taught you this. This is present in interstellar stars. Where it is present, guys?
Interstellar stars.
Interstellar stars means in between stars. Interstellar stars, it is present. So this is called as C60, which is like a football shape. What is that? Football shape. Examples of fullerene is C60. Actually C35 to C70 will be carbon numbers is varies. This all called as fullerenes only. So these are both semiconductors. What we should call? Semiconductors, and as well as understanding, and also sometimes they are superconductors. What is that? Sometimes they are superconductors. So anyhow, these fullerenes are it is not there for you, but this diamond and graphite we have to use. So if you'll observe here, graphite is what, guys? Graphite is the only exemption which is the good conductor of electricity. So this is what graphite is called as what? Allotropy of carbon. What we should call? Allotropies of carbon.
Allotropy of carbon.
Allotropy. What do you mean by allotropy? Dina, Pranav, anybody? Pranita, what do you mean by allotropy? Because what do you mean by allotropy? Same chemical formula, but the chemical formula is same, but different physical structure. But different physical structure. That is what we should call it as allotropic. Please, all of you remember. Now, two examples main. What is that? Graphite. Second one is diamond. Next one is fullerenes. Okay. Remember, fullerenes are in understanding spherical football shape. Fullerenes are in what? Football shape. Okay. Now, diamond is in. Remember, all of you. Now I am saying you. Hepta plus hepta, octagonal structure. What is that? Octagonal structure. Octagonal structure. Understand, guys? Tell me, tetra plus tetra will become octagonal structure. Graphite is totally 5, correct? It is hexagonal structure. 1 minute, 5 only. Correct. So, because of hexagonal structure it is. So this is the graphite structure. Remember this. So because of this hexagonal structure, graphite is having free electrons. What is that, guys? Graphite is having free electrons. Understand?
Free electrons.
What is the reason? It is what? A good conductor of? Good conductor of what? Electricity. So that is the reason you can see in the electrolysis process. In the process of electrolysis, we have a electrodes. Do you remember, guys? Electrodes. Please respond me. So if you take any kind of electrolysis process, middle we will keep 2 solid rods. Is it yes or no? One is taking the electricity inside and another one is taking the electricity outside. Please respond, Mira. Yes or no? Varshini, this is called as electrodes. These 2 are called as electrodes. Basically, these electrodes in the electrolysis process is made up of water. Is made up of graphite. Understand, guys? Because it is very good conductor of electricity. Please remember this. So they will ask you what is the importance of graphite. So graphite, which is an allotropic form of carbon, and to experiment and demonstrate the understanding like conductors of electricity, we are using this one in making electrodes. Where we are using, guys? Electrodes. Do you remember?
Electrodes.
The solid substances is called as electrodes. Basically, they will make cheap and best graphite only. Understand, Ra? That is what. So if you observe here, to conduct electricity, even we can see when class 8, when you are in class 8, I have told you, I only told you to prepare that. Take 2 pencils and sharpen them both the sides. Do you remember this activity to prove that graphite is a good conductor of electricity? Is it yes, guys? You have to take the 2 pencils and you have to connect these 2 pencils with one LED. With one LED, if you connect, then what will happen, guys? If you make anything, like for example, if you have been connected to the one source of battery, then you can see the bulb will start glowing or not glowing, Ra? Glowing or not glowing?
Glowing, sir.
Glowing. So if
I
you
see in science projects.
yes, science experiment, you people have done this. I know that. Class 8, I also told you. Have you remembered, guys? 80 classes, respond me. So, from this activity, what we people will feel, guys? You please tell me. So, we will prove that graphite is a good conductor of electricity. Or else, you can say. So, another experiment you can take. For example, I will take a bulb. We have to prove that sulfur and phosphorus are not good conductors of electricity. They are bad conductors of electricity. So what we should take, guys? We have to take 2 crocodile clips. What we have to take, Ra? 2 crocodile clips. Now, here, in this case, bulb will glow or not glow? You shall respond me. Bulb will glow or
Not glow, sir.
not glow. Now, here, in place of this, between this crocodile clip, if I'll place the sulfur metal or phosphorus, is it possible to glow the bulb, Ra? Everybody, bulb does not.
No, sir.
No, sir.
Why? Because they are bad conductors.
Bad conductors of electricity.
But in place of only non-metal, it is a good conductor. That is also allotropy of carbon. What is that? If you place the graphite, just your pencil, if you will connect, then it will start glowing. Because graphite is the only one which will conduct water, which will conduct electricity. That is, you have to remember it. Understand, guys? except that do not conduct any other thing. Any doubt in this? Please respond me. This is the second property of physical property of non-metals. Now, let us go to the third property. Third property what guys? Anybody? Arya, Karthikeyan, Nitinath, respond me. Everybody. 21 or 20 students are there. Nobody is responding. Ashika, Bhumika is not there. Why she is not understanding? Nitish, respond me. Nitish, Dilipan. What is this third property? So is it there dull in appearance or shiny in nature? Third property. Is it
Dull in
there?
appearance.
No. They
Dull
are
appearance.
lustrous in
Dull
nature.
appearance. Dull
Yes.
appearance.
Dull
So,
appearance.
non-metals. Exceptional cases are there. Non-metals are not lustrous. Understand, Karthikeyan? Not lustrous means in the sense of not shiny in nature. So not shiny means how their appearance, Pranita? They are
Dull, sir.
dull in,
Rough.
dull in nature. So
Dull in nature.
all the metals, all the non-metals, they do not have shiny surface. They are dull in appearance. Understanding, Ra? So if we'll take
Dull in appearance or rough in appearance.
also, this is also applicable for what? Applicable for only what? Solid non-metals. What is that, guys? Solid non-metals. Understand, guys? Liquids and gases, we people cannot say that it is lustrous or not. It is applicable for what? Solid non-metals. Understand? So only solid non-metals, dull in appearance. So if we'll take, wait, Kevin, I will say. So if we'll take here, understanding again, for example, two non-metals only. Again, what is that non-metals? I'm call to Bhumika and Elmati also. Padmavarshini, are you there? So please respond. Again, what is the examples of dull in appearance? Again, sulfur and what are Dina? Pranav?
Phosphorus.
Sulfur and phosphorus.
Sulfur and phosphorus.
That is you should remember. Phosphorus is dull in appearance. So they do not have any kind of shining surface. Do not have any kind of shining surface. That is you should remember it. Now, if you'll observe here, anyhow they are dull in appearance, but one exemption is there. That is what? The only non-metal which will having lustrous appearance. Kevin said diamond also. Now, Kevin, diamond will reflect the light, not lustrous in nature. Understand, Kevin? Okay, Kevin. So,
sir.
only non-metal, which non-metal, Ra? Solid non-metal, only non-metal which is having, understanding, lustrous appearance is iodine.
Iodine.
Remember, what is this, Ra? Lustrous appearance.
Iodine.
Only iodine. So many times this bit they used to ask in exam. So the only non-metal which is lustrous in nature is iodine. Understand, guys? Arun, tell me, Arun. That is, you have to understand it. Is it okay, guys? Please respond me. Kevin, Ashika, Pranita. That is. Call to Jesse. Next. This is the fourth property. Now what? Third property. Next, what is the fourth property? See the physical properties of metals and tell me, Nitish. What is that? They are generally what? They are soft or hard. Non-metals are generally non-metals. Non-metals are generally what, guys?
Soft.
Generally soft in nature, so that we can cut with a knife or we cannot cut with a knife. We can cut with a knife or we cannot
Cut with a knife.
We can cut with a knife. Understand, guys? So easily cut with a knife. Easily cut with a knife. Again, which non-metal? Solids, liquids, or gases? Which non-metal?
Solid, sir.
Which one?
Solid.
Cut with a knife. Understanding? All only solid non-metals. Is it possible to cut, Karthikeyan, liquids and gases? Is it possible to cut? No.
No, sir.
If you'll observe, easily cut with a knife, only that is also solid non-metals. Again, example. Anybody example? Well-known examples are, again what?
Sulfur and phosphorus.
Phosphorus. Understand, Ra? Sulfur and phosphorus. So here also, only exemption is there. The naturally hard substance. More than metals, the naturally hardest substance, well known to the that is the only
Diamond, sir.
understanding. Hardest in nature, hardest natural substance. natural substance which is equals to what, guys? Diamond. Understand? So this diamond is what? Another allotropy of carbon. What is that? Another allotropy of carbon. Understand, Pranita, Tarani, Harini, everybody? That is, so the only non-metal, understanding, that is also not direct. It is the allotropy of what? Allotropy of carbon. Understand, guys? Allotropy of carbon, that is what we should call it as diamond. It is the naturally hardest substance, natural substance that is known to us, that is diamond only. So which is also one form of carbon. So this is the fourth property. Now coming to the fifth property of non-metals. Anybody? Is it they are strong or else they are easily can broken? Non-metals, please respond me. Non-metals are not strong. Non-metals are not strong. So that, is it possible to use them in construction of bridges and all? Is it possible to use them in construction
No,
of?
sir.
No, sir.
No.
sir.
They are easily broken. What is that? Easily broken. That is the reason. Understand, Ra? So graphite is a non-metal. For example, if you take understanding which can easily broken, that is graphite only. Simply in our sharp
Pencil. Needle also.
even kid also can break the graphite. Is it yes or no? By keeping inside the sharpener. Yes or no? So the graphite is a non-metal which is not strong. So that we can say all the non-metals having what? Low strength. What is that, guys? They are having low strength. They are not enough strong. Understand? But here also you have to remember, diamond is the hottest substance which we are used to use to cut even metals also. What we are doing, Dina, Pranav is also absent. Nitish, please respond me. What is that? We are using diamond even to cut what? To cut metals also. That much strong it is. Understanding? That is the naturally hottest substance. So this one, they are not enough strong because of low strength. You can see. Understand? So when a large weight is placed on a graphite sheet, for example, say one stone I will hit on the graphite pencil. What will happen, Ra? It will break it into pieces. Is it yes or no? So if you place a large weight, understanding? So non-metals, solid non-metals, they will be brakes. So brakes, another word I said, vocabulary. Can you remember and tell me? Brakes means also you can call it as what? Snap. What is it called? Snap, not brittle. Snapped. Understand, Amma? Snapped, we can say. That is what we should call that. So this is the fifth property of non-metals. So now next one, can you able to say what is the sixth property? Very easy. So how they are existed at room temperature? At room temperature they are existed at what? Please respond me.
Melting.
Yeah. So non-metals, understanding, they existed maybe in what, guys? Maybe existed in solid.
Melting point.
Yeah. No. So liquids and as well as what? And gases. Room temperature. At where? At room temperature. Understand? So for example, so that we can say non-metals are existed in how many states, guys? How many states? Solid state, liquid state, gaseous.
Gas.
Okay. So the only liquid non-metal is called as what, Radina? Arya? Bromine. Understand?
Bromine.
Only non-metal which is present, Yalni, understand, Yalni, which is present in the liquid state. So if you take examples of solids, anybody? Examples of solids what? Carbon,
Sulfur, phosphorus.
understand?
Carbon.
Examples of gaseous, examples of gases.
Nitrogen, oxygen, carbon dioxide.
Nitrogen, oxygen.
Carbon dioxide, a bad fellow. Carbon dioxide is a compound, Ra. It won't come. Nitrogen, chlorine, Understand, Ra? That is, understand, chlorine, you have to remember. Hydrogen, oxygen, chlorine, understand, nitrogen, fluorine. This is what we should call as gaseous non-metals. Is it okay, guys? This is the examples of it. Understand, Ra? So, this is all about the sixth property. Now, coming to the second, helium. Helium also you can take. So, now, if you take the seventh property, now you tell me, they have a low melting points or high melting points. Please tell me.
Low melting point.
Low melting point and
So non-metals have a comparatively low MP and BP. What do you mean by MP, guys? Low melting point.
Melting point and boiling point.
One thing, except one substance. What is that? Naturally hardest substance.
Diamond, sir. Diamond.
So please all of you remember. So except diamond and understanding, which is having a non-metal having a very, very high melting point at boiling point. Except diamond, you have to remember. So for example, if you take melting point of sulfur, what is that? Melting point of sulfur. What is the symbol of sulfur, Ra? Varshini? Yes, which is equals to just 150 degrees Celsius. How much, Ra? 115 degree Celsius, but it is very quite low. Is it yes or no? Quite low temperature. So that is why we can say melting point of basically all the metals, like solid metals like phosphorus also, it is very less value. That is why they will say compared to the metals, their melting point is very low. But if we'll take exemption, what I said, diamond. Understand? Diamond melting point is more than metals. What is the iron melting point, guys? Please check your notebooks and tell me. Prasini, Yalni, Nitish. What is the melting point of iron? 1500? Please respond me. 1500? Nobody is saying. 1500 and what? 35 degrees is the melting point of iron. Correct or not? But if you take the diamond, it is almost double to the iron. That is what? 3,500 degrees Celsius. Very more than metals. Understand, guys? Please respond me. Diamond is melting point is what? More than metals. This is the only exemption. Everybody should remember.